This video presents a personalization of a cyber defense system against phishing, which takes into account the user's awareness level. In the case of phishing, an attacker prepares emails as if they were sent from legitimate entities. In an example case, a victim receives an email and clicks the link in the email, and she will be redirected to a fake website which appears legitimate in terms of appearance. Furthermore, the only difference between this fake site and the legitimate one it is trying to pose as is the information in the browser's address bar. Users who remain unaware that the website is fake are prompted to input their account information, which is then obtained by the attackers who created the fake website. Within the context of personalization, Nekoma recognizes there are different types of users. Novices often fall victim to phishing attacks. Conversely, experts can potentially distinguish fraudulent websites from benign websites. Novices do not have rigorous criteria while assessing a website's credibility. Therefore, they do not have concrete knowledge of things like domain name and security information. Instead, they tend to assess the credibility of a site based on its web content. It is this tendency which allows attackers the opportunity to fool users by simply mimicking the benign content of a legitimate website, thereby tricking people into believing that they are accessing the real website. In the Nekoma project, the behavioral differences between novices and experts are analyzed to provide cyber defense. This video shows the record of eye movements of a novice user while they were browsing phishing sites. The circle represents the point at which the user is gazing. As you can see, this user tried to verify the legitimacy of this website based primarily on its web content, and eventually, this user regarded this phishing site as legitimate. In the case of legitimate sites, the same user is also looking mostly at the web content and ignored the address bar. On the other hand, this expert user checked the address bar at the start of their browsing session. In both cases of phishing and legitimate sites, the expert user's knowledge of URL and SSL aided in their decision-making process. Cognitive psychology enabled us to distinguish novices from experts. We monitored users' eye movement at specific areas, observed eye fixation and its duration on those areas, and estimated users' internal intention. In roughly 80% of the cases, we could determine which of the users were more likely to become victims of phishing attacks. We collect eye movement information and inform the defense system about the type of user. The defense system, implemented as a browser extension, selects the type of cyber defense. We have two anomaly detectors. One type is lightweight, but has high precision. The other is a deep inspection type and achieves higher recall. The defense system and detector modules are interconnected via Nekoma's information pipeline, and hence, the modules leverage the threat analysis platform and the information is pipelined to each component. How does the system work? At the start of the browsing session, the web input form is deactivated. Even if a user sees the content, the form will not work. Once the system senses that the user is viewing the address bar, the form will be made available. We also developed this for tablet and smartphone devices, although such devices have limited screen size. A small eye-tracking camera connected with a tablet works to provide a defense system similar to that of the version used by desktop PC users. Set of experiments, we can observe the characteristics of the two modules we developed. A lightweight detector works even when the number of clients is increased. But the deep inspection method only requires 2.5 seconds in the worst case. Security usually penalizes convenience, so we asked our 14 participants to rate their perceived level of inconvenience. The predominant answer was that users weakly disagreed with a perceived loss of convenience. We intend to disseminate this work in 3 ways, namely, education, open source, and international standardization. We started to educate school children of the importance of checking the address bar, published our developed tools and solutions as open source programs, and proposed standards for improving situational awareness. In this standard, we provide recommendations for developers to design good user interfaces in order to protect various types of users from phishing attacks. Thank you very much for your attention.